Let us present this particular graph, or chart, or bar chart. What we're looking at is the application of 670 nanometer wavelength of red light. And the results are as follows, as you could go along and look ahead and reference that bar chart. A 15-minute exposure to 670 nanometer light, red light, reduced the degree of blood glucose elevation following glucose intake. It was 75 grams of glucose just added to water, and then to drink it down within 2 minutes. By 27.7%. They didn't even round up. They stuck right to that number, 27.7. Integrated over 2 hours after the glucose challenge. Maximum glucose spiking was reduced by 7.5%. Now, I want you to keep an eye on that flashlight there, the 690 nanometer wavelength being exposed to the back, because that's part of the methodology. So it gives you a little bit better insight. So that's just the beginning. That is just with the application of light therapy. Something which has basically breached that Rubicon and once maybe considered new agey. Now we are heading to a new vector in medicine, which is very, very heavily integrated into regard to vibrational and light medicine. Pretty interesting, pretty neat. Now let's get right into the study as follows, because it's really exciting. As we proceed, red light can reduce blood glucose levels. It's something called photobiomodulation. So CPBM, that's photobiomodulation. To proceed, the researchers found that 770 nanometers of red light stimulated energy production within the mitochondria, tiny powerhouses within the cell, leading to increased consumption of glucose. In particular, to reiterate, it led to a 27.7% reduction in blood glucose levels following glucose intake and reduced maximum glucose spiking by 7.5%. Previous research established that long wavelength light between approximately 650 and 900 nanometers, spanning the visible through the near infrared range, can increase mitochondrial production of ATP. All the athletes, their ears listened up, which reduced blood glucose and improved health and lifespan in animals. We're going to go some highlights in regard to that in a second. But to proceed, they'd also say that this improvement in ATP production can cause signaling changes that are transmitted throughout the body. So there you have the ATP levels, the mitochondrial production, and the glucose begins to go down, correlation-wise. To proceed, they suggest, quoting, it may be mediating the abscopal effect, which is actually really kind of a cool effect, a reference to oncology, which refers to the phenomenon, abscopal palmitate, it's a form of vitamin C, abscopal, which refers to the phenomenon in cancer treatment where a specific irradiation of a primary tumor can result in shrinkage of secondary tumors located in different parts of the body. Henceforth, the abscopal effect. Likewise, 670 nanometer light shown selectively onto the backs of mice. Now keep in mind, these are human subjects in this particular study, but then in other studies, they worked with mice. On the backs of mice in previous studies has been shown to result in improvements in ATP, adenosine triphosphate, for the Krebs cycle, citric acid cycle, ATP cycle, whatever you want to call it, that improves symptoms in both model of Parkinson's disease and diabetic retinopathy. So again, ears, listen up, because this wavelength of light, in regard to how it impacts ATP positively, can have many other venues in regard to correlating with other typical modalities. To proceed, the methods, real important, very simple. To explore the impact of 670 nanometer red light on blood glucose, the researchers recruited 30 healthy participants who were then randomized into two groups, 15 minutes in the 670 nanometer red light group and 15 minutes of the placebo. Remember, they showed it on the back, so the participants couldn't see whether they were getting light or not. Pretty cool. They had no known metabolic conditions and were not taking medications. Participants were then asked to do oral glucose tests and record their blood glucose levels every 15 minutes of the next 2 hours. People who received red light exposure 45 minutes prior to drinking glucose exhibited a reduced peak blood glucose level and reduced blood glucose level during the 2 hours. To reiterate, 15 minutes of 670 nanometer light on the back. So This way, keep it in perspective or context. The methods, a little more into the details, which again, very important. The upper back, 670 nanometers for 15 minutes, 800 cubic centimeters region. The light intensity, etc. you can follow through. 45 minutes to prepare to consuming the glucose, which was they had to consume 75 grams of glucose in water. And of course, they shone that light for how long? 15 minutes. To proceed. Some interesting notes. You ready for this? Check this out. Single exposures to 670 nanometers of light, which they used in the study, can be effective within 3 hours. So within 3 hours, this begins to work. It can have an impact for 5 to 7 days. Can you imagine that? If basically, in order to help stabilize blood sugars, it just required a little bit of exposure to red light, and henceforth, boom, it worked as simple as that. That's adding publisher bias in reference to a hypothesis, but still, it'd be kind of neat if it panned out to be true. To proceed, this is kind of like the negative aspects of light. Exposure to 450 nanometers, which is the dominant peak in LED lighting in the built environment, results in significant and rapid reduction in blood pressure in humans and also significant increase in heart rate. So it's kind of interesting. You go into a typical building that may have this particular LED light, which I assume is very common. Blood pressure drops. Sounds good initially. Heart rate begins to increase. Interesting. Both shifts persist during exposure periods. Experiments using 460 nanometers photobiomodulation, PBEM, in human subjects similarly disrupted physiology, significantly increasing blood glucose levels during exposure. So 468, not so great in helping maintain the blood glucose. 450 nanometers, not so great as far as helping maintain a harmonious heart rhythm. Interesting, the power, the incredible power light waves can have in regard to photobiomodulation as being a tool for good or not so good. To proceed, conclusion. It is clear that light affects the way mitochondria function, and this impacts our bodies at a cellular level and physiological level. Our study has shown that we can use a single 15-minute exposure to red light to reduce blood sugar levels after eating 670 nanometers, according to the methodology, and receiving the same outcome in regard to the study. Quote, while this has only been done in healthy individuals in this paper, it has the potential to impact diabetes control going forward, as it could help to reduce potential damaging glucose spikes in the body after meals. So you can imagine this really, the interesting part about it, you have to keep this in mind, the participants didn't see the red light. So think of it this way, and this is conjecture and interjecting a little bit of publisher bias, meaning my own opinion. So you can have this red light exposure in the back, doesn't have to be visual. This photobiomodulation could then basically activate your ATP in a positive way, henceforth help stabilize your blood glucose levels without you ever having to see the light. Imagine something like maybe a strap on the back that it basically generates 670 nanometer light in regard to maintaining your blood glucose levels before you go out eating or dining or indulging. So it's a pretty cool, or let's say this, the ATP generation prior to exercise or strenuous activity. That can yield tremendous benefit for athletes. Again, that's publisher bias meaning my own opinion or conjecture interceding into this particular study. But still, just the same, pretty amazing. Again, gratitude to the researchers. Incredible research like this comes out on a daily basis. It just never hits the news channels. So again, keep your ears open and your eyes alert, if that's such a thing. By gratitude for this being presented to us, so I could share with you. And I humbled you watch and look forward to seeing what you and I share next week. Catch you all next time. Bye.